Hello, my name is Sid Jasti. I go to the University of Maryland. I'm a current rising sophomore. I'm originally from Kansas City, but I've been in College Park, Maryland for about a year and a half. And if Angelina, you want to introduce yourself too?
Hi, I'm Angelina. I'm also a rising sophomore. I go to Harvey Mudd in California, and I'm from Southern California.
Okay, so I'll go ahead and share my screen and get started with the presentation. Okay, so as I said before, my name is Sid Jasti, and my project this summer was matching globe land cover observations with satellite data. And my mentors this year were Kristen Weaver and Holly Cole. So just a synopsis of my project and what I've been working on. So as many of you know, the Globe Observer project and the app is made to allow users all over the world to make their own scientific observations. There's four categories right now, which is land cover, cloud cover, mosquito habitats, and tree height. My specific project is working with the land cover observations, and it's building a match table using HTML and CSS, along with some Python scripts to give the user a table that provides their observation that they took from the app, as well as satellite observations taken from the sky from numerous satellites. So right now with the app and with the Clouds team and Tina Rogerson, we have a Clouds current Clouds table. So as you can see on the right side of the column, you have the Clouds observation. So, the date, time, latitude, longitude, and then various other observations. As you can see, it's well organized, aesthetic, has a lot of information, which is good for the user as they can compare and contrast their observations with observations taken from satellites in the sky. And then provide some other information like surface conditions and a box to submit a comment if you have any thing you'd like to add. So I based my table a lot off of this, took inspiration from this because it's already doing it well. So why reinvent the wheel? So my first design for a table, as you can see, is in that same format. I have this globe observation on the left side, which includes the land type, field notes, etc. For many of you who are not familiar, the land cover observation, unlike clouds, has some different observation types, obviously. So the user will submit a few photos of the land that they're surveying, along with some descriptions like field notes, descriptions of the land type, and then their recorded land cover type, which is forest, greenlands, urban, etc. The problem with this table, however, was that it would have trouble being read by a screen reader, and this was kind of jumbled, and it seems like the information is just plopped onto there. So using the help of Heather Mortimer, we designed a better table that's kind of experimental, but that acts like a clouds one, where it's not just so jumbled and kind of lays out the information more neatly. So this is our final design. As you can see, I kept that same header, with the NASA logo and the title, satellite match table. It has three main boxes. I'll go into the bottom two later, which is the satellite data. That top box is the globe land cover observation. So when a user records their observation, they'll get this table in the email after a few days. And obviously that first box is stuff that they've seen. This is the observations that they made. This specific, example observation was taken from Kuwait. But this stuff they'll already know. This information they'll be familiar with because they were the ones who recorded this observation. So we're just displaying this so they can compare with the satellite data. So just to go into a little bit of the satellite data and where does the data come from. So we're using four main satellites to display on the table. The first two I'd like to go over are Landsat and the Sentinel-2. So both these images are both RGB images. Landsat 8 and 9 and Sentinel-2 are very similar. They both have two satellites. The Landsat has Landsat 8 and 9. Sentinel-2 has Sentinel-2A and B. The Landsat satellites have 11 bands. Sentinel-2 have 13 total. And they use the same combination of 2, 3, and 4 to comprise an RGB photo. So I'm extracting each separate band and layering them on top of each other to produce this red, green, and blue photo. These highlights are really good because since there's two to each mission, they always work on opposite sides of the Earth. So even though one satellite for Landsat would take 16 days to go around the globe, since you have two of them, you'll always have a satellite a Landsat satellite survey the same area on the Earth every 8 days, which is great because if you have an observation, you'll have a photo within the last 8 days for Landsat and the last 5 days for Sentinel-2. With the processes, Landsat we're using Google Earth Engine and a little bit of post-processing to make the image a little bit more visible. And then Sentinel-2 we're using the Sentinel Hub, which is a platform that's worked with the ESA, the European Space Agency, and we also provide a worldview link, which I'll go into later. The next two satellites we use and the last two are Sentinel-1 and then the MODIS. So Sentinel-1, as you can see in the image, isn't easily interpretable for someone who hasn't seen Sentinel-1 imagery before. And this is because, unlike Sentinel-2 and Landsat 8 and 9, Sentinel-1 uses SAR technology, which stands for Synthetic Aperture Radar. And this is different because instead of using visible light spectrum, it uses microwave to detect land cover. So this is great in some ways because obviously, microwaves are different than visible light. So these microwaves are able to pierce through clouds and being able to detect land cover day and night. So whereas with these two imageries, we filter for cloud cover. So we're saying, okay, we want the latest image from this date with the earliest image with less than 25% cloud cover. With Sentinel-1, we don't have to do that. We'll always have the latest image since we don't have to worry about cloud or day and night. It's really good. Sentinel-1 is really good for ocean observation. Since it can pierce through ice, it can look at depths of ice, depths of water. Good for ocean, with the water level from the ocean, and just to kind of better interpret this, as you can see, like this land area is like the white kind of describes like the land area, and then the black is like the water. This happens because how the SAR works is that it shoots microwaves to the Earth, and then detects how many microwaves are coming back. So with the bright areas, that's usually land or man-made structures, and this is good because, it shows bright because those microwaves are bounced off the land and detected by the satellite, whereas water and roads, which are kind of smoother surfaces, are more black. As you can see here, the roads are kind of darker gray, and then the water is almost completely black because the water absorbs a lot of these microwaves and doesn't really reflect it back. You can imagine like shining light through water; it's not going to really reflect back. And then with MODIS, this is our kind of unique data. Since it's not really an image; it's more of a description. But MODIS is an instrument on the Terra and Aqua satellites. MODIS itself offers 36 spectral bands, and we're just using a combination of a few to determine land cover type. So like the user describes a MUC code, whether it's like a grasslands, urban, forest, water, etc. MODIS can do the same thing from the sky. This database is yearly. It's updated yearly. For now, for some reason, it hasn't been updated since 2019. So the earliest data set right now is from 2019. I think due to COVID or some other delay, the data hasn't been compiled yet. But in terms of a yearly database, it's not a big deal because land cover type doesn't really change that often. So getting a yearly update isn't the worst thing. And we also provide a worldview link for this. So let's kind of go back to that table, and I'll exit out of the slideshow and kind of show you guys the table. So this is how it would look like when a user gets it. Like I showed earlier, you have this kind of the user observations. So you can click on each of the images and it'll open them up into a larger format. Because they're kind of small here, you can look at them in a bigger format. And then you have your more interesting information that's new to the user. You have your MODIS instrument data and your satellite images. Along with these photos, you can also click on these photos and it'll open up into a bigger format. So as you can see, this is Sentinel-1 image. You can see earlier I was talking about, this water area is more black, gray, while like the land and buildings are more lighter white, gray. Same thing with Sentinel-2. You can click on these photos, open them up. And with Landsat 8 and 9, since we're doing some post-processing, I've drawn a box to kind of show this 100 meter by 100 meter. That's like the sample size for the globe observation, while the surrounding area is, zoomed in from the satellite. And you can see here, there's a dimension for this image is 1,000 by 1,000 meters, when this box is 100 by 100 meters. And I kind of touched upon the NASA worldview links earlier, but one of the great things about this table is that we provide this NASA worldview link. So I'll start with MODIS. Go and click on it. It'll bring you to a worldview, which is a great tool. And this is a good thing to include in the table because, for me, especially before this internship, I wasn't familiar with Worldview. I never heard about it before, but it's a really cool tool to look at a lot of data sets. And you can, so that was taken in this area of Kuwait, and you can see it's describing on the left side here water bodies. That blue color is water bodies. So describing where it gets that data from, and then you can zoom out, allows users to kind of mess with this tool and look at other parts of the world if they want to. And we have that same thing for Landsat Sentinel. So if you click on Landsat, you have Landsat's imagery for that area within this date, July 25th. So we also provide these links to allow the users a more interactive map where they can kind of look around, pan around, and get more familiar with the tools that NASA provides. And then finally, with this table, we include a link here to open up to the Global Observer website, which is not implemented yet, but will be implemented within the near future, which will kind of describe everything I described on this slide, talking about how to interpret the data, where this data comes from, and what these satellites mean and what these satellites do. So last thing I want to go over is just like kind of the back end, how it works, where I'm getting the data and how I'm storing it. So initially, when we get a observation, so let's say a user will submit an observation that is stored in the Globe database. So I'm using Python with the Globe API to collect the latest entry. So I gather from the internet using API the latest entry. So I'm including I'm getting all like the data that they submit, like field notes, the images, the MUC classifications, getting all the imagery and information and storing in the database. And then I'm also getting the coordinates and time, putting them in a PostgreSQL database. And then once that information is stored in the database, then we go and trigger the satellite scripts. So the two most important values in this Postgres database is the coordinates and the time and date, because these are what these scripts use to get that satellite imagery. So once that's in the database and these satellite scripts are run, and we're saying, okay, so for Landsat and Sentinel-2, we want the latest image with less than 25% cloud cover for this specific coordinate area of like 1,000 meter by 1,000 meter area. And then using the Earth Engine API for Landsat and the Sentinel Hub for Sentinel-2 and Sentinel-1, we're getting that imagery and then putting it back in the database. So now once all the information is stored in the database, we finally use PHP with the HTML and CSS match table, and then finally compile all that data into more visible, viewable, interpretable table that's then sent to the user via email. So kind of in conclusion, this project allows users to receive informative and rewarding feedback for their observations and incentivizes users to submit observations and also to include all observations in the table, because you can see here that some categories are required, like the surface conditions and field notes, surface conditions is required, but field notes, MUC classifications, and some of these images aren't mandatory or required. But if you don't have those, then it'll just show not classified or not recorded. So the more data you have, the more data you can compare with the satellite images down here. And this project can still be expanded. So hopefully after my internship, the team will still expand this, making data sets of all the possible match tables for land cover, where people around the world, researchers, students, teachers, etc., can use those data sets to make their own studies. And like the clouds table, we want to add a submit section so people can submit their comments, and then hopefully in the far future make similar match tables for the mosquito and tree height observation categories. And this is just another example of NASA, the great projects we do in NASA and Globe Observer, and how Globe Observer is bridging the gap between NASA and citizen scientists. And finally, I just want to give big thanks to my mentors, Kristen Weaver, Holly Cole, and Heather Mortimer. They were super welcoming for me this summer, showing me all around Goddard. Were super nice, and I learned a lot from them, as well as the rest of my team, Tina Rogers and Agnes Conti and Jessica Moe, who were super helpful, helping me whenever I had questions, just welcoming me to the team. And I had a really nice time this summer. And also everyone who's helped me along the way, the Fresh Eyes on the Ice team, Christopher, Melanie, and Dana, as well as Michael Taylor, Ross Walter, Eric, and Ella, who helped me interpret satellite imagery, understand how the satellites work, and be able to compile that RGB photo, for example. And then also a shout out to Caleb, Stefan, Brian, and Rob for helping me. Thank you.
Excellent. Thank you very much, Sid. So I think should we do a few questions for Sid to begin with, and then we'll move over to Angelina, who has a question.
That was super interesting. I just wanted to ask if you're storing all of the data that you get for your satellite match tables.
Yeah. So I mean, like how the database works right now. I mean, I haven't integrated completely, but it's kind of like an Excel sheet. You can visualize it. So you have like different columns. So you have like your ID. We make a unique ID for each observation, which is a combination of like the date and time, the site ID, and then their user ID. And then we have different columns for the globe, the different globe values, surface conditions, etc., as well as like the satellite data, the imagery, the links to the images, the worldview links, all the stuff that's put in the table. But like I said in the conclusion, we don't have a database for like just to like link to the database, link to the match tables themselves. I haven't integrated that, but hopefully that'll be there in the future. But yeah, like you're saying, it'd be really nice to have that just so you can have quick access to a multitude of tables.
Yes, Sid, this is super interesting, super needed, and we're just so excited about what you've done today. I can see how it could be potentially implemented, in the context of our citizen science program, and that can have, really significant implications. So really kudos on what you've done. You did talk about all the different, several different kinds of products that you looked at, including Sentinel-1, 2, and Landsat, and MODIS products. It sort of went by me really fast, but I know you talked about the worldview links. So are you actually in this table? What are you actually linking? All those different products, or just the MODIS product, or what is actually the outcome?
Yeah. First of all, thank you. I'm also very thankful to be part of this team.
Oh yeah.
And I can go ahead and share my screen and just go over that. We have 3 worldview links. So right now we have kind of 4 satellite categories.
Mm-hmm.
We have this MODIS data, and then we have the 3 different satellite images.
Uh-huh.
So worldview doesn't have a database like to the show for Sentinel-1 because it's not NASA to ESA, but Sentinel-2, Landsat 8 and 9, and then MODIS have worldview links. So this is that worldview link. I'll just click on it. So you click on this, it opens up this worldview link for MODIS. So it loads. You see like that's the layer here, and it has the different land cover types on the left. So this is where it was taken. My test table was taken from Kuwait. That was some observation taken from Kuwait. But we can zoom out and come to anywhere in the world, and you can see the different types of land cover types. So it's it really encourages the user to experiment with this database and tool and just kind of mess with it and get used to it. Because for me, the first time I saw this, I was messing with this for like an hour or so, just seeing the different data sets. And you have that same thing for Landsat 8, and then I'll open for Sentinel-2 after. This is a harmonized data set between Landsat 8 and 9. And then just taking that, that reflectance from those 3 bands, to second, third, and fourth. Obviously, this comes in strips because that's how the orbit is. So if you want to adjust the date down here, you can, and then you get different date times.
Yeah.
And then same thing for this one. I don't think I put the date correctly in this one. It's the 26th, yeah. And then you have that same thing, basically same thing as Landsat for Sentinel-2, but, different orbit time, and yeah, you can adjust the date. And it's also harmonized from 2A and 2B, obviously. So yeah, so those 3 MODIS or worldview links we're showing, and I did forget to specify in like the presentation that we get the land cover classification for MODIS down here, showing water bodies. At least 60% of the area is covered by permanent water bodies, and this is meant to display so the user can compare this with their MUC classification. So this is the overall classification for the whole land. So they'll compare these two and be like, okay, my classification was open water marine. Okay, cool. MODIS is the same, the same thing, water bodies. They also have their separate MUC classifications for each of the 4 direction, the cardinal direction photos. This one they're saying water. This one they're saying water, urban, and then trees. So yeah. So the worldview link kind of provides that interactive map where they can also look at other areas.
Okay. The MODIS classifications, though, they are they are at what scale? What is the granularity of those images?
Yeah, I think it's 500 meters by 500 meters. So obviously, like it's a little bit zoomed out compared to the 100 meter by 100 meter. So if you can imagine, it's like half of this box. So yeah, I mean, Kristen was kind of explaining to me how, it's not always going to be like 100% accurate, just because she gave me an example of, you're taking a land cover observation of a park in the middle of a forest. So, the user's classification might be an urban area because it's a park, but the MODIS will look at the overall picture and say, okay, it's a forest, so I'm going to classify as a forest. So, in this link to interpret the match table, we're going to specify that, the MODIS classification is taken at a less of a scale from the sky, so it's looking at more of an area of land. So user can understand that it might always not be accurate, and that's why.
Okay, great. And I'm just asking questions because I'm super interested, not because it's in any way a criticism at all. So the other question I had is, you showed us an image of a map product which was showing land cover. When in this match that you have created, you have also linked to secondary products, land cover map interpretations as well, or just the satellite data? Just satellite images.
Yeah, I'm just I've just linked to like those Landsat 8, 9, Sentinel 1. I just linked the links. I haven't linked to like the tools I used. I mean, I'll talk about them a little bit in this link. I'll talk about like Earth Engine and then Sentinel Hub a little bit. But I don't have there's no like publicly available like description of of like the tools I'm using. But I have written documentation for my code describing basically each line of the code and like how I'm using these tools. So if anybody ever wanted access to that, obviously that's for my team, and I'm sure anybody can access that. So yeah, I think that's not available right now, but hopefully after this is over, Mentorship is over, and this is implemented, can be available for people to look at.
Okay. Just to jump in, Drusty, I think one of the reasons we did the MODIS was because that's what you see in the app right now. If you go to the My Map, that's the base. So, but if there's another data set, I think something that I know there's planned to be one based on, I think, the Landsat or harmonized Landsat Sentinel data land cover map at some point globally, and then we could expand or update SID's work once that becomes available. But it's using the MODIS classifications because that's what we have in the app right now.
I think that's a good answer, and I know other people have questions, so thank you very much. Absolutely wonderful, Sid. This is something we've been wanting for years, and I think you've taken us a long way down the road. Thank you.
Thanks so much. Appreciate it.
And do you see, so a question from Andrew in the chat regarding Landsat RGB composite. You mentioned post-processing. What processing steps are you alluding to other than overlaying the 100-meter square? Am I correct in assuming this was completed on Google Earth Engine? Do you want to talk a little bit about that? And I think also you referenced, but you might also talk a little bit about the filtering for cloud cover percentage.
Yeah, so basically, Michael Taylor showed me a lot about what he does with imagery, and I use kind of the same process. But what he does is he mainly does the imagery through Photoshop, which is obviously different than what I can do with Python. So he just layers the RGB images on top of each other, and then he just shows some process of not like, it's somewhat like increasing saturation where you're matching every color pixel to make the image more colorful, because the image I kind of display is a little bit more murky and gloomy. But yeah, so right now the process I'm doing is when I download the GeoTIFF file, it just has the separate bands as like an array value. So what I'm doing is I'm extracting the second, third, and fourth bands. So RGB is just values for each red, green, and blue color, and then I'm just getting that red color from like each pixel color for the red, each pixel color for the blue, each pixel value for the green, and then just making an RGB value for each pixel, and then combining that all into one photo. So it does take a little bit of time, but yeah, in terms of like post-processing, I'm just increasing like the saturation brightness a little bit, and drawing that box over it. I'm not like, the limitations of working with Python and downloading those Google Earth Engine photos is a little bit difficult, but if you have any suggestions, I'd be open to that. But in terms of post-processing through GEE, I don't think the Earth Engine does a lot of post-processing with the data. I think it's just mostly raw data, especially with the GeoTIFF file that is downloaded. Does that make sense?
But you are running, I think what's also significant that you mentioned was that you are looking for, because there's a cloud cover percentage noted with the images. So you're not just looking for the most recent, but also filtering for the ones that are that have low enough cloud cover.
Yeah, and that was the problem I had initially when I was getting photos. Like some of them would be cloudy, you couldn't see the land at all. So filtering for less than 25% cloud coverage is important, just so we can get a clear photo.
What particularly interesting challenges do you think you came across? Something that you haven't talked about yet? Was there anything that you thought was sort of an interesting challenge to solve, or something new you were exposed to, or something you found interesting while you were doing this?
Yeah, I'd say there's obviously the challenge of just like learning some of the languages. I mean, I was already familiar with Python and like web dev, but in terms of like the database management and communicating the HTML page with the database and then the Python script with the database was challenging because I hadn't had much experience with SQL. So learning that language and then integrating it with the page and then the Python scripts was challenging for sure. But probably the most challenging, but also the most like fun, interesting part to me was understanding the satellites and interpreting the images, especially for Sentinel-1 that doesn't use visible spectrum, because with Sentinel Hub it's a lot easier to interpret the image, but you have to filter through like the backscatter and get the correct. There's like a big process you have to do with Sentinel-1 and how it works. Basically, it has like two different hybridizations, I guess, where it would shoot like vertical beams down to the earth and then get the horizontal beams back, and filtering those and getting the right bands and was definitely hard for Sentinel-1. But the Fresh Eyes on Ice team helped me with that a lot because they have experience with Sentinel-1 data, and yeah, just getting over that challenge of understanding how that satellite works was challenging but interesting.
Okay, well, thank you so much, Sid. It has been really a pleasure to work with you this summer, and I appreciate Sid has been, all of these. Didn't talk about some of the little challenges that he had. That often he would come and say, "I was having this problem, but I already solved it." So, yeah, it's been really enjoyable. So, thank you so much, and we'll look forward to with like the next steps are having Tina implement it. Hopefully before too long. So that's kind of hopefully the next steps. So, thank you very much, and we'll turn it over to Angelina.
So starting with just the My Observations page. The My Observations page is user specific. Every user can log in and see all of their observations for a given protocol. And so, for example, this is a My Observations page just taken off the website. It's a random user that I was able to find just through some web searches. And as you can see, he has his chart with the clouds, his images, and then his data. All his data is listed there. And what I have been working on for this project was to implement a satellite match row. So I have my implementation. It's a satellite match row that reads either not available, pending, or the name of the satellites that you match to. So there are 5 satellites each cloud's observation can match to, which include Geo, Terra, Aqua, NOAA 20, and Calypso. Just a quick introduction to Geo and Aqua. Geo, Aqua, and Terra, if you match to multiple satellites at once, they will all appear on the same page, just like this. Geo, Terra, and sometimes Aqua. If not, if you only match to just one satellite, then you will just have Terra or Aqua. Aqua is now retired, so that reads NOAA now, and my code does work to read for NOAA and Aqua. So it reads for all time frames. And the more challenging satellite to match to get your matches to is Calypso, because Calypso has a whole new satellite match page that is not with Geo, Aqua, or Terra. And so Calypso has its own page that looks something like this, much different from the rest of the satellites. And so what my code does is, if there is a satellite match, it finds the page, it reads the page, and then reports back all of the satellites you match to. If there is no match, for example, if I just make this ID some random number, there's two possibilities here. Your match does not exist. If you're on the page and you have an observation, your observation will exist, but your match may not yet because NASA has not received or matched your match yet. So this is one possible page you can receive. And if you receive this page, my code will read pending. I believe I have an example here. It's just you have an observation, but your match the satellite match has not been correlated with your observation yet. And if you have no match, for example, this observation has no match. If you have no match, it'll say no corresponding satellite data found. You can still reach this page, but it will not be useful to most, so my code just reads not available. Besides this, I also implemented a change to the visual graphics of the My Observations page. As you will notice, there are arrows and indicators on desktop. However, on a normal My Observations page, if you make the observations page the size of a mobile screen like this, the indicators for the arrows and the indicators for the images will disappear. So I worked to fix this code, and now if you take a look at the fixed version, even though it is the same small size, it still has the indicators and it has a gradient in the background to improve visibility, along with a drop shadow to, again, enhance visibility. Another implementation I made to this page is also to show only satellite matches. So this button filters all of your observations and collapses all observations that do not have a satellite match. So here we see GEO, this one has GeoNOAA, this one has GEO, and this one says not available. When we click this button, it will collapse all of those that say not available, and you should just see all your satellite matches with a matched satellite, which is shown here. And that's about everything that I've implemented this summer.
Well, thank you, Angelina. And I think just a little added explanation, some of these things have been things that, have come up from users, and especially we had, teachers trying to find for their students satellite matches. And it was, you have to kind of dig into Viz and find them. And this will be a much easier way to get access to that information. So I think this will be really helpful. Any questions for Angelina?
Oh, sorry. I forgot to add on something.
Yeah, go ahead.
So this is only for clouds right now. If you notice, it has this satellite match row added for clouds, but if you switch to another observation type, it does not have that.
Which hopefully, the combination of your work and Sid's work, once we get the satellite matching for land cover implemented, we can also then implement that for land cover, although it will be a little simpler because there will always be a satellite match for land cover, unlike for clouds.
Yes.
Any questions for Angelina? Sid, go ahead.
First of all, great work. It's like a lot behind this. I can tell behind the scenes, change the URL and everything. I guess I'm not super familiar with how the app was coded or the framework behind that, but what was the framework you used to make that application?
So this is just a web page right now, and in the app, when you click My Observations, it brings up the web page in the format of the app. So it just brings up the web page in the sizing of your phone or device you're looking at it on. And so that is what happens when you access My Observations.
Right, thank you.
Do you want to talk a little bit, Angela? I know you had some challenges related to figuring out when the match exists or not. Do you want to talk a little bit about your process for doing that and some of the things of trying to implement that?
Yeah. So Joe and I, well, Joe has mentored me this summer, and Joe and I came up with a really interesting, I find it to be really interesting way of determining whether there's a match or not. So because all satellite matches have almost the same URL, let me share my screen again and demonstrate this. So satellite matches have a sort of formulaic URL. As you can see, each match has something in common. They all start with this first bit of text, and then the only difference in every single URL is going to be the ID at the end. So every single web page starts with this school, LARC, NASA, Gov, satellite match observation. And so the way we determined whether or not there was a satellite match was through web scraping. And web scraping basically goes through every single, it doesn't go through every page because that would be extremely impractical and it would be very taxing on Tina's server. But what it does is that it takes your observation ID, which is found within this cloud's data, even though it's not shown, and then it checks each page for it. It takes the observation ID, puts it into this web address, and checks if that page exists or not. And if it does exist, it reads the page, and if it doesn't, it reads something else back to you. And the way we formatted this was we only wanted to check one at a time, not simultaneously hit Tina's server with like 40 or 50 checks at a single time. So we would check one by one for up to 20. And then once it hits 20, if you want to see more, you can scroll all the way down to your page and say load more, and it will hit one by one, but each are paced out and spaced out.
But I think this is a nice way to do it, because previously, if you want to, like, I know I've definitely gone into GlobeViz looking for an example of a satellite match, and you have to click on a bunch and say, open a new tab and see, oh no, that has no match. That only has geo. I'm looking for one with Terra. And so this will be really nice to be able to just scroll down and see that, and doing it without kind of having to make changes to what Tina's doing at the back end, kind of just working with what she has. I think that was a really clever solution for that. I appreciated it. Anybody else have questions for Angelina? Okay, going once, going twice.
Well, I would just like to thank Joe for all his help this summer. Priscilla helped me with some last minute changes yesterday, Priscilla Moe. And then Roger Rose gave some really great suggestions along with you, Jessica Taylor, and Holly. And this can be expected to go live pretty soon, I believe. I will commit the changes later today, and whenever they push out the next update to my observations, it will be live and everyone can see their satellite matches. Thank you.
That's really excellent. And again, thank you, Angelina. I didn't get to work quite as close with you as I did with Sid this summer, but I did. I appreciated watching your thought process as you were working through things, and really coming up with some good suggestions that I think made some improvements, even things we hadn't necessarily asked for. The show only the ones with the satellite match, and that's a great innovation that'll make it, I think, a lot easier for people to use this. So. Anybody thought of anything they want to ask either Angelina or Sid before we sign off?
I have a question about what Angelina just said about it being promoted and going live. I don't think you could scrape the data right now until I get changes on my end, which isn't going very smoothly. Yeah. So I don't think it should go live until we can resolve the issue with you being able to scrape my data, or Globe being able to scrape my data.
Not necessarily like live. I was just going to it to the source code for further approval on the Globe Observer side.
Okay.
But yes, I did forget to mention that one big part of this before it goes live, quote unquote live, is that Tina's satellite match pages do have a level of security to them that I bypassed with a plugin on my computer. However, not everyone will have that plugin, so we do need to wait until we have approval to bypass that security measure.
Always something. There's always some challenge that you don't expect, that you go into thinking you're gonna solve it one way, and then you have to figure out a different way to work around it. So, but I think we'll get there. Hopefully, we'll get there. Okay. Well, thank you again so much to Sid and Angelina for showing us what you've been working on this summer, and yeah, we've appreciated having you. And I know Angelina is sort of a longer term intern for Autumn, so we'll continue to see you in your comms aspect, maybe, even though this was a diversion into computer science. Thank you, everybody. Have a good afternoon.